Good day, everyone. We are here again in my channel to explore and study science, particularly physics. We have discussed scalars and vectors, vector addition, graphical solution, and the triangle method. This time, we will continue discussing about resultant vector, and we will focus on another method of finding it. Addition of vectors using the component method. In our previous discussions, we have found out that two or more vectors can be added or combined into one single vector. We term this vector as resultant vector. This single vector contains all the added vectors. Say this vector A is added to vector B, and the resultant vector is vector R. We use vector equation. Vector R equals vector A plus vector B. This means vector R contains vector A and vector B. What if you are given a vector like vector R, directed at theta sub r, acting on the first quadrant? By projecting to the positive y-axis, the component of r along the y-axis can be obtained. Can be called vector r sub y. And by projecting towards the positive x-axis, the component along the x-axis can be obtained. Can be called vector r sub x. What can we say about any vector? Any single vector like vector r contains vector r sub x and r sub y. These vectors r sub x and r sub y are the components of vector r and can be obtained along the x and along the y axis. This is vector r and its components r sub x and r sub y. These vectors can be arranged this way. Vector r sub y can be positioned from the tip of r sub x following the polygon method. How is the x component of the vector obtained? By defining the angle theta sub r. In trigonometry, the trigonometric function of this angle theta sub r is defined by the ratio of the sides of the triangle, such as cosine theta sub r is equal to the ratio of the adjacent side, r sub x, and the hypotenuse of the triangle r. Sine theta sub r is equal to the ratio of the opposite side, r sub y, and the hypotenuse r. The tangent theta sub r is equal to the ratio of the opposite side, r sub y, and the adjacent side, r sub s. From these definitions of the functions, the x component, r sub x, is equal to the product of r and cosine theta sub r. The component r sub y is equal to the product of r and sine theta sub r. Example, vector r is equal to 120 newtons, 40 degrees. What are the values of r sub x and r sub y? After calculating, r sub x is 91.93 newtons directed towards the positive x-axis, while r sub y is equal to 77.13 newtons directed towards positive y-axis. How are these values obtained? First, let's have a review about the angles and values of x and y components in its quadrant. This axis showing the positive x, negative x, positive y, and negative y divides the space into 4 quadrants. This is the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. The angles within the quadrants measure at quadrant 1 between 0 and 90 degrees. Quadrant 2 between 90 and 180 degrees. Quadrant 3 between 180 and 270 degrees. And quadrant 4 between 270 and 360 degrees. The components in its quadrant. At quadrant 1, both positive x and y components. At quadrant 2, negative x and positive y components. At quadrant 3, both negative x and y components. And quadrant 4, positive x and negative y components. Going back to our example, how is r sub x and r sub y obtained? The magnitude of vector r is 120 newtons and the direction theta sub r is 40 degrees. The required are r sub x and r sub y. The formula to use to obtain these components are r sub x equals r cosine theta sub r and r sub y equals r sine theta sub y sub r. Substitute the magnitude and direction of vector r. R sub x equals 120 newtons times cosine 40 degrees. The value of cosine 40 degrees is 0.766. The magnitude of r sub x is 91.93 newtons. R sub y is 120 newtons times sine 40 degrees. The value of sine 40 degrees is 0.643. R sub y is equal to 77.16 newtons. Thus, the answers are r sub x equals 91.93 newtons and r sub y equals 77.16 newtons. Vectors can be broken into its components. The x component can either be directed towards the positive x or towards the negative x. The same with the y component. It can either be directed to the positive y or negative y axis. The components of the vectors added can be used to determine the resultant vector. This is what is called component method of vector addition. Find the resultant vector of these vectors. Vector A, vector B, vector C, and vector D. The directions of the vectors measured from the positive x-axis, theta sub A, theta sub B, theta sub C, and theta sub D. The x components of the vectors are A sub x, B sub x, C sub x, and D sub x. The y components of the vectors are A sub y, B sub y, C sub y, and D sub y. The components of the vectors acting along the same axis can be added algebraically. Summation x or r sub x is equal to the sum of a sub x, b sub x, c sub x, and d sub x. Summation y or r sub y is equal to the sum of a sub y, b sub y, c sub y, and d sub y. The sum of the components summation x or r sub x and summation y or r sub y are perpendicular to each other and forms a right triangle when illustrated with the resultant vector. R sub x can either be towards the positive x-axis or negative x-axis. R sub y can either be towards the positive y-axis or negative y-axis. A positive r sub x and positive r sub y have resultant in the first quadrant. The direction theta sub r from the positive x-axis measures between 0 and 90 degrees. The angle opposite the resultant vector r is 90 degrees. Negative r sub x and positive r sub y, when added, results to a vector acting along the second quadrant. The angle theta sub r is measured from the positive x-axis and measures between 90 degrees and 180 degrees. The angle opposite the resultant vector r is 90 degrees. Negative r sub x and negative r sub y have resultant acting on the third quadrant. The angle measured from the positive x-axis measures between 180 and 270 degrees. The angle opposite vector r is 90 degrees. Positive r sub x and negative r sub y have resultant acting at the fourth quadrant. The direction theta sub r measures from the positive x-axis and the angle measures between 270 and 360 degrees. The angle opposite the resultant vector r is 90 degrees. Because the triangle formed is a right triangle, then the sides of the triangle are related by the Pythagorean theorem that r square is equal to the sum of the squares of r sub x and r sub y. Or the magnitude of the resultant vector r is equal to the square root of the sum of the squares of r sub x and r sub y. When the resultant is acting on the first quadrant, the direction of the resultant from the positive x-axis is equal to the inverse tangent of the ratio of r sub y and r sub x. When the resultant is acting on the second quadrant, theta sub r is 180 degrees plus the inverse tangent of the ratio of r sub y and r sub x. At the third quadrant, the direction of the resultant from the positive x-axis is 180 degrees plus the inverse tangent of the ratio of r sub y and r sub x. At the fourth quadrant, the direction from the positive x-axis is 360 degrees plus the inverse tangent of the ratio of r sub y and r sub x. You may ask, why the formula of theta sub r on the second quadrant and the third quadrant the same? No, they are not the same, because the value of the inverse tangent of the ratio of r sub y and r sub x is negative in the second quadrant while positive in the third quadrant. Now let's have an example. Find the resultant vector, its magnitude and direction. The figure shows for vectors A, B, C, and D. The magnitude and directions of the given vectors are 100 meters, 70 degrees, 60 meters, 0 degree, 80 meters, 135 degrees, and 90 meters, 270 degrees, respectively. The required in the problem are vector r, magnitude r, and direction theta sub r. For the formula, the resultant vector, vector r, is equal to the magnitude of the vector in its direction. The magnitude of the vector is the square root of the sum of the squares of r sub x and r sub y. General equation, but to be finalized based on the location of the resultant, theta sub r is equal to the inverse tangent of the ratio of r sub y and r sub x. The sum of the components of the given vectors along the x, r sub x, is equal to a sub x plus b sub x plus c sub x plus d sub x. The sum of the components of the given vectors along the y, r sub y, is equal to a sub y plus b sub y plus c sub y plus d sub y. As a sample formula for the x component, a sub x is equal to the product of a and cosine of theta sub a. And the y component of a sub y, is equal to the product of a and the sine of theta sub a. Continuing with the problem, the components of vector a sub x and a sub y. Substitute and calculate a sub x, which is equal to 100 meters times cosine 70 degrees. The value of cosine 70 degrees is 0.342. Thus, a sub x is equal to 34.2. The y component of a sub y is equal to 100 meters times the sine of 70 degrees. The value of sine 70 degrees is 0.940. When multiplied, the y component of vector a is 94 meters. This illustration shows vector b and the x component of the vector and the y component. B sub x is 60 meters times cosine 0 degree. Cosine 0 degree is equal to 1. Thus, B sub x is equal to 60 meters. The y component of vector b is equal to the product of 100 meters and sine 0 degree. Sine 0 is equal to 0. Thus, b sub y is 0. For vectors along the positive x-axis, the magnitude of the x component of the vector is equal to the magnitude of the given vector, while the y component is 0. The third vector is vector c with a magnitude of 80 meters, acting on the second quadrant. The x component of the vector is directed towards the negative x-axis, and the y component is directed towards the positive y-axis. To determine the magnitude of the components, c sub x is equal to 80 meters times cosine 135 degrees, measured from the positive x-axis. The value of cosine 135 degrees is negative 0.707. When multiplied, the x component of vector c is negative 56.56 meters. The y component of the vector is 80 meters times the sine of 135 degrees. The sine of 135 degrees is positive 0.707. Thus, the y component of the vector is 56.56 meters. How about the components of vector d? The x component and the y component. The magnitude of the components The x component is 90 meters times cosine 270 degrees. The cosine of 270 degrees is 0. Thus, the x component is 0. The y component of vector d sub y is equal to 90 meters times the sine of 270 degrees. The value of sine 270 degrees is negative 1. Thus, the y component of the vector d is negative 90 meters. We have to determine the sum of the components along the x and along the y-axis. Substitute the computed x components of the vectors. R sub x is equal to the sum of 34.2 meters, 60 meters, negative 56.56 meters, and 0. The result of R sub x is 37.64 meters. The sum of the y components of R sub y is equal to the sum of 94 meters, 0, 56.56 meters, and negative 90 meters. R sub y equals 60.56 meters. When illustrated, the R sub x and R sub y and the resultant vector, as well as the direction from the positive x. Notice that both the sum of x component R sub x and the sum of y components R sub y are positive, and the resultant R is acting on the first quadrant. Knowing that R sub y is perpendicular to R sub x and will form a right triangle, the Pythagorean theorem will be used to obtain the magnitude of the resultant vector, which is equal to the square of 37.64 meters plus the square of 60.56 meters. Performing the operations, the magnitude of the resultant R is 71.30 meters. Inasmuch as the resultant vector is acting on the first quadrant, the direction theta sub r is equal to the inverse tangent of the ratio of 60.56 meters and 37.64 meters. The ratio of 60.56 meters and 37.64 meters is 1.609. Thus, theta sub r is equal to 58.14 degrees. Stating completely the resultant vector. Vector r is equal to 71.30 meters, 58.14 degrees. Let's have another example. The following forces act on an object resting on a level, frictionless surface. 10 newtons to the north, 20 newtons to the east, 10 newtons at an angle 40 degrees south of east, and 20 newtons at an angle 50 degrees west of south. Find the magnitude and direction of the resultant force acting on an object. This is the illustration of the forces acting on the object. Notice that the direction used in the forces is a combined angular and wind direction. These directions must be converted to pure angular direction before continuing with the component method. The given forces with pure angular directions are F sub 1, 10 newtons, direction, theta sub 1, 90 degrees. F sub 2, 20 newtons, direction, theta sub 2 is 0 degree. F sub 3, 10 newtons. Direction, theta sub 3 is 320 degrees. F sub 4, 20 newtons. Direction, theta sub 4 is 220 degrees. The problem requires to determine the resultant vector, the magnitude of the resultant vector, and the direction of the resultant vector. To solve this problem, the formula to use is vector f sub r is the magnitude and direction of the resultant vector. The magnitude of f sub r can be obtained using the Pythagorean theorem. And the direction theta sub r depends on the location of the resultant vector. If it falls in the first quadrant, theta sub r is equal to the inverse tangent of the ratio of r sub y and r sub x. The sum of the x components equals f sub 1x, f sub 2x, plus f sub 3x, plus f sub 4x. Likewise, the sum of y components of the forces is equal to f sub 1y, plus f sub 2y, plus f sub 3y, plus f sub 4y. To determine the components of its force, x component is the product of the magnitude of the vector and the cosine of the direction from the positive x-axis. The y component of its force is the product of the magnitude of the force and the sine of the direction from the positive x-axis. A table can be used to help facilitate solving the problem. First column, the vectors. F sub 1, F sub 2, F sub 3, and F sub 4. Second column, the magnitude of its vector. 10 newtons, 20 newtons, 10 newtons, and 20 newtons respectively. Third column, the direction of its vector from the positive x-axis. The next column will be the x and y components which are to be solved. Substitute and calculate from the formula presented earlier. The x component of f sub 1 is 0. The y component of f sub 1 is 10 newtons. Remember that f sub 1 is a vector acting along the positive y-axis. The x component of f sub 2 is 20 newtons. The y component of f sub 2 is 0. Note that this vector is acting along the positive x-axis. The x component of f sub 3 is 7.66 newtons. And the y component is negative 6.43 newtons. The x component of f sub 4 is negative 15.32. And the y component is negative 12.86. Write the values of x components obtained on the table. And write the values of y components obtained on the table. Now find the sum of the x components. The sum of the x components is equal to 0 plus 20 newtons plus 7.66 newtons plus negative 15.32 newtons. The sum of x components is 12.34 newtons. Write the result on the table. The sum of the y components is equal to 10 newtons plus 0 plus negative 6.43 plus negative 12.86. The sum of Y components is negative 9.29 newtons. Write the sum of Y components on the table. Substituting the sum of the X components and the sum of Y components to the Pythagorean theorem formula, the magnitude of the resultant force is 15.45 newtons. Notice that the sum of X components is positive, while the sum of the Y components is negative. This shows that a quadrant where the resultant vector up is the fourth quadrant. And that fourth quadrant is equivalent to between east and south. In the fourth quadrant, the direction of the resultant vector theta sub r is 360 degrees plus the tangent of the ratio between the sum of the Y components, negative 9.29 newtons, and the sum of X components, 12.34 newtons. Theta sub r is 360 degrees plus the inverse tangent of negative 0.753. The inverse tangent of negative 0.753 is negative 36.98. Theta sub r is equal to 360 degrees plus the negative 36.98 degrees. So theta sub r is 323.02 degrees. The direction of the resultant obtained is in pure angular direction. It should be converted or expressed as combined angular and wind direction, just like the direction of the given forces. 323.02 degrees in pure angular is equal to 36.98 degrees south of east in the given direction. Write this on the table. State completely the answer. Resultant force vector F sub r is equal to 15.45 newtons, 36.98 degrees south of east. Write the answer on the table. Write the final answer completely. 15.45 newtons, 36.98 degrees south of east. After the discussion on resultant vector using the component method, now it's time to test your understanding. Solve the following problems employing the component method. The first problem is, Peter walked from his house to school. From the house, he walked 120 meters, 30 degrees south of east. 200 meters towards the south, 150 meters, 40 degrees south of west, 100 meters towards west, and reached the school gate after walking another 70 meters, 20 degrees east of south. What is the location of the school from Peter's house? The second problem is, two billiard balls are rolling on flat table. One has the velocity components v sub x equals 1.0 meter per second, v sub y equals negative 2.0 meters per second. The other has the velocity components v sub x equals 2.0 meters per second, v sub y equals 3.0 meters per second. If both balls started from the same point, what is the angle between their paths? Solve these problems on a clean sheet of short bond paper. One paper per problem. Show your complete solution and have your answers checked by your instructor or professor. That ends our video lesson on resultant vector, component method. Hope you have acquired what you are supposed to learn from this video lesson. If you find this video helpful in your studies and you feel that other students may also learn from this, like and share this video. If you want to see more videos from this channel, please like this channel. Thank you for watching. God bless and good luck.